Here we go. So first one you guys should be pretty comfortable with, right? It's not power reducing, obviously, it's double angle, but quadrant 2. And that'll be 12 and 13, -5. So cosine 2x, you could probably do, you can have a few options, up to you. What if you do 1 minus 2 sine squared x? I mean, that's pretty easy. Actually, you don't even need to do a drawing. So you have 2 times 144 over 169. Which would be 1 minus 288. Should be negative 119 over 169, I think. Yeah. Let's try 2. So 2, they want you to rewrite a sine, cosine, tangent of a double angle. I think that's pretty obvious. It's going to be cosine 2 theta, or cosine 270 degrees. And of course, that answer is going to be 0. No, yeah, 0. Yeah. But next one's a good one. We'll try this verifying identity problem. And is that Catherine? Welcome. And Ryan, welcome. So we're doing a verifying identity problem right now, just some problems I'm putting up. You'll want to start out by doing this. Your goals make it look like the other side. You'll definitely have a double angle to work with. Hopefully got this, sine x. Cos 2x, you should know this is 3 variations, but I do 1 minus sine squared x. Make that a little more easier to read. That's 2 sine x cos x. And then you can convert cosine squared 1 minus sine squared. So this could be like one of the medium level identities that I said, I, I could have. and then distribute, and you should get it all to work out pretty nicely. Let's see here. I don't get -4 sine cubed x though.
I think it's because for the double angle for sine, it's 2 sine x cos x. So on the left, when you're multiplying 1 minus sine squared x, it would be 2 sine x times that.
Wait 1 sec. Oh, you're right. Duh. 100% correct. Thank you. Yes. Yeah, I knew something seemed off. Thank you for catching that. Yep. Then we got it verified. Yep.
Mr. E,
Yeah. So let's try exercise 4 next. Yeah. Go ahead.
would you consider like that last one, like what level of difficulty would you
Medium.
consider the
Medium.
last one? Medium?
Medium.
Okay.
Yeah. All right. Let's try this one next. Exercise 4.
Sorry, I have a really quick question.
Mhm.
Oh, I get the last one. Is there any chance you could scroll up to the one before that just so I could write it down? I just didn't get a chance to.
Sure. Here we go.
Thank you. Okay, thank you.
So let's try exercise 4 next. Yeah, so you want to get down to powers of 1. You guys must work this one out. You can definitely be using power reduced formulas here. So hopefully you're getting this so far. 8. We could, well, if we do, think about the power reduced for sine squared x. And that's just like just rearranging the double angle formula for cosine 2x, right? So you can think of it as 8 times 1 minus cosine squared, or 4 parentheses 1 minus cosine squared, 2x. Then for the cosine squared, let me think about this one. Cosine squared x is 1 plus cosine 2x over 2. So this 1 plus cosine 4x over 2. Yeah, and if you distribute, you should get actually, hold on, I think I did something wrong here. Oh, I messed this up, guys. Sorry. I messed up pretty hard. Wait, did I? No. I think I
Is it
got it.
supposed to be -4 minus 4 cosine x? Because in the next step.
Hold on.
Also, do you have to distribute in that case?
No, not necessarily, but I just want to make sure I've. Wait. Okay, what the heck? Yeah, hold on. I clearly did something wrong here. So something's not right. Let's go back. Yeah, because sine 4x is clearly that.
When you see
And
the
then, okay.
sine x to the power, oh sorry, when you see the sine x to the power of 4, are you supposed to take the sine squared x and then square that identity?
Oh, shoot, you're right. 100% correct. Yes.
Okay.
Yes, you're correct. I knew something seemed off. Or I guess you could, yeah, okay. And then you could do cosine squared 2x. Or I think we could also do this too. Yeah, because you're doing that twice, right? And cosine squared 2x.
Doesn't multiplying it by itself kind of take away the need for the cos squared in the parentheses?
Well, oh, right, you're right. You're correct. You're correct. You're correct. Right. Sorry. Okay. Yeah, in 8/4, that's just 2, so I can just get that out of the way. So that's 1 minus 2 cos plus cosine squared 2x. There we go. Yeah, and the cos squared 2x is that. So you have 2 bracket 1 minus 2 cos. And then plus, yeah, the 2's cancel. Yeah. Okay. Yep. Okay. That next one's kind of easy. I mean, if you don't remember the half angle forms, you can always derive it. Like for example, I believe that's correct. Oh, sorry, it's cosine. Got the
Yeah,
wrong
because
formula.
I know. Yeah, that's what I was thinking.
Yeah. And cosine of x over 2. So you can kind of figure out what tangent would be.
It's just sine by cosine, so it's just 1 plus divided by 1 minus.
Right. So wait a moment for you guys to work that out.
Mr. E.
Yep.
There's a tangent identity in the, I think it's
Yep.
in the classwork.
Yeah,
where it's
sine x over. I mean, if you have that memorized.
Yeah, but I guess I was wondering, like, when you simplify it, why does the plus or minus go away when you have 1 minus cos x over sine x? Or is it because it can be positive or negative because it's not in a root, or?
Well, yeah, when you divide the 2, good question actually. Because you wind up getting root. Well, I think what's going to happen is that you're going to wind up. You could think of it like this then. You multiply by itself. Yeah, because then you get root 1 minus cosine squared x. I'm not sure why actually. You get 1 plus cos x, and that sine squared x up top comes sine x. Yeah, I'm not sure why that goes away.
So is it safer to just not use it, or?
Yeah, I'm not sure why it goes. Yeah, I'm not sure why that goes away. But anyway,
Okay.
you wind up getting sine x or 1 plus cos x, and then 1 plus cos x cancel, and you have it verified. So, and if you know the form right away, more power to you. Okay, so that's some stuff with a half angle. Let me see if I can locate some other good problems. Let's see. No. I don't like those. Hold on.
I'm just wondering if there's any way we could get some like, or we could get like access to that, those review problems that we were just looking at.
Yeah, I could download it. Hold on.
Thank you.
What would be like a really hard identity that
I
you
know.
like?
I'm trying to find it right now. Give me a sec. Yeah, let's go to some of my files.
Uh, also, do you have any more like tangent half angle identity like practice problems? I feel like we didn't spend a lot of time on that.
Okay, hold on. Actually, I did find some hard ones. Let's try those. So start part A. Let's verify that identity.
So would you want us to start from left side or right side for A?
Let me think about this one here.
I was thinking about starting with the right side, but
Yeah, hold on. I'm trying to figure this out. Give me a sec here.
sure thing, yeah.
Um, Actually, that might be a little too. Hold on. Actually, no, let's not do it. Let's not do A. Let's do B instead. Yeah, let's do B instead. I think B is more appropriate. And for B, probably best to work on the right side. Okay, so how's it going here so far, guys?
I couldn't do it with the right side, but I found it easier to use the left side.
Left side. Maybe it was left side then. Hold on. Actually, I think the left side does make more sense the more I think about it now. But you could try doing a power. I wonder if we could try doing a power reducing form on the right side. But yeah, if you did 2 times cosine, is that how you start, Kate? Is that how you got started? I should have started over here. Yes, you do 2 cosine minus 1. All right, sorry again. I keep losing my connection. Here we go. So, yeah, let's work on the left side. And then you could add 1 to both sides. Or no, sorry, not do that. Sorry. I was thinking of sine equation. Yeah, then you could do the sum difference formulas. And then you could then convert those. You probably can make that cosine squared theta minus sine squared theta. You've got that twice. And that will be -4, because you have 2 sine theta, cosine theta. So it'll be -4 sine squared theta, cosine squared theta. Minus 1 equals the other side. Then you do get, this is really nasty. You get cosine 4 theta. You get -2 sine squared theta, cosine squared theta, plus sine 4 theta. This is where I'd then use a power reducing formula. There's a 2 right there. Yeah, I totally use the power reducing formula at this juncture. I'd have 1 minus cosine squared. No, it's cosine squared 2 theta. That takes me backwards. You could convert that to I guess you can make that 1 minus sine squared theta times 1 minus sine squared theta. Yeah, I think that should work out. Because you get 1 minus 2 sine squared theta plus sine 4 theta. because it's cosine squared times cosine squared. It would cancel with that sine 4 theta. Or would it? No, it would not. Shoot. Okay, I'm a little stuck here. Okay, you said it was pretty easy for you. What did you do?
Oh,
So
no. I thought it worked, but it didn't work, so I'm confused too.
Yeah. So I'm almost there. But I need yeah, I'm just trying to think here.
Yeah, I just like got stuck with an extra -4 sine squared theta that I don't know how to.
Right. I'm a little bit
I was able to do it on the right side.
that's what the solution queue says. So let's go back to the right side. So yeah, you can make that one. Well, that's where I'd use the power reducing formula, right? So you could say 1 minus 8, and then you could do 1 minus cosine squared. So 1 minus cosine 2 theta, and 1. Yep. Okay. And that's 1, and then you get -2. Yeah, then you get 1 minus 2 cos 2 theta plus cosine squared. Hold on. Oh no, it's difference of squares. So 1 minus cosine squared 2 theta. There we go. Okay. And that would be, yeah, cosine 2 theta. What option could I use? So it's cosine 2 theta. That's being squared. So I could think of it as maybe cosine squared theta of a multiplied by itself.
can that reduce down again into like 1 plus cosine 4 theta if you reduce or go up again?
Oh, you're
And
right.
that's how the 4 theta
Do
comes
another
up?
power reducing. Yeah.
Yeah, exactly. Yeah.
No, you're right. Good call.
I just forget the
Yeah, so 1 minus, so it'll be 1 minus 1 plus cosine 4 theta over 2. Right. And then you distribute that. So 1 minus 2 minus 1 plus. Okay, I think we're. One sec. So make sure I make a mistake. Yeah, I do get a -1. Oh yeah, and it's 2 over 2, but it's also 2. No, 2 cancels 1. Well, something seems a little off here. But no, I'm on the right track. That's for sure. Shoot, hold on. Get 4, that's 2, 1. Yeah, so you should get 1 plus cosine 4 theta over 2. And it's 1 minus that number. 2 on the outside. I think it's a 2 though. That's what I'm really confused about. And it's still 1 minus, I know that. Yeah, I'm a little confused about that. I don't know if maybe there's a mistake with this one, but that's what you. Yeah, I think we just have to move on, guys, because it's just taking forever. Well, let's try. Let me go to some of my equation problems. Let me just pull up a different document that I know is a little more reliable. I'm trying to find stuff online for you guys, but or let's just go through the practice test. Let's do that. If you guys haven't done them all. Yeah. Go me to the one at the end. Let's do a solving problem. Problem number 8. Okay. Let me pull the solution key.
Mystery, I just want to let you know, I plugged the equations into Desmos and they weren't the same. So
Oh, the identity.
Yeah, they were.
Yeah,
It was
so they
supposed to
probably
be
messed up.
16.
Yeah,
Yeah.
they probably messed up. Yeah, the power reducing was the way to go. Well, what number are we just looking at? Great. Why is that equation look different? Oh, that's weird. Looks like out of place. Here's the solution to that one. Okay. Let's try another one. Let's do this actually. Let's do let's see here. This is a good one. Why don't you guys try that one?
Would you rather us use like the addition
Yeah,
formula
right,
or
right,
the
right,
half
right. The
angle?
addition. I did the addition formula. You
Would you
could use
mark it
half angle. No,
if, okay.
no. So anyone have an answer we want to share?
Yeah, I got √2 minus √6 over 4.
Sounds about right. Wait, hold on. There we go. Yeah, okay, we got it.
For those, do you need to rationalize it if it was
well,
one
well,
over root
actually, the
two?
denominators are rationalized anyway.
Okay.
I mean, you can rationalize numerator, then you have denominators are radical. I mean, it's up to you. Yeah, let's do another solving equations, 2-6.
Mr. Reed, I have a question about the practice test.
Yes, go ahead.
So on practice test number 1, I think, like, in order to prove the identity, you needed to use the difference of cubes.
Oh, I'm not gonna ask you to do anything like that.
Okay, yeah, like, because we learned it, but like we haven't learned
We
it.
haven't practiced it. No. Wait, which one is it? Sorry.
It's number 7 on test 1. Practice.
Oh
test
yeah,
1.
no. Don't worry about that. That's crazy.
Okay. Okay, thank you.
Mr. Reed, do you mind if I ask a quick question?
Good.
Do you mind like clarifying when we're supposed to check for extraneous solutions again? Like I know we're always supposed to check, but are there specific
Always,
cases we should,
always,
no matter what?
always. Yeah.
Okay, there's no like indication of like I really
No,
need to check on
no,
this problem.
no,
Okay.
no. Always. So you should be getting this as your answer. Any questions on that one? No.
Not really, no.
Okay. Let's come back to the practice test again. Let's take a look at let's do 10. Back to verify again. This will be the last one we'll do for tonight. So you should have sine x It's actually pretty easy, guys. This is one of the easier ones. Okay. So cool. We'll just go and end there for tonight. I'm gonna go and stop the recording.